So let's continue to our playlist. But before that, hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is check if a given linked list is palindrome or not. So what is the problem stating? You'll be given the head of the linked list and you have to check if it is palindrome or not. Now what is the definition of palindrome? Anything written in reverse should be the same. So basically, if you're given a string, something like mom, and if you try to write it in the reverse order, M O M, it's the same mom, right? So any number, any string, any given thing, if you try to write it in the reverse order, it is the same. It is the same. Then you call it as a palindrome. Now, what is the definition in terms of linked list? You cannot just pick up the data. You cannot pick up the data and write it in a reverse order. What you will do is, you'll take the last, place it, 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 and then compare. If they are equal, they are right. So if such is the scenario, you will be returning true. Otherwise, you'll be returning false. So the question is stating, given a linked list, so basically you'll be given the head of the linked list, you'll have to return true if it is palindrome, you'll have to return false if it is not palindrome. So this is the case for odd length of linked list. What is for the even length? It's the same thing. You take the last, take the second last, the third last, fourth last, fifth last, and the first one. So if you again compare, they are similar. So this is also a palindromic linked list. Let's look at another example. You're given 1, 2, 3, 2, 3. Let's try to write it. Take the last, and if you write it, you will see that they are not matching. If they're not matching, you'll be returning false, stating that it is not a palindrome. Now, what if this question comes up in an interview? What is the extreme naive solution that you can think of? Like what I can think of is, I need to preserve them. So what I'll do is, probably I'll take a data structure. Let's take a stack data structure and we'll understand why as we move forward. And initially, let's keep a temporary pointing to the head of the linked list. What is the data at temporary? 1. Take it and put it into your stack data structure. Remember, stack is a last in, first out data structure. Remember this. Let's move to the next. What is the value? 2. Put it into the stack. Let's move to the next. What's the value? 3. Put it into the stack. Let's move to the next. What is the value? 2. Put it into the stack. Let's move to the next. What is the value? 1. Let's move the temp. And you reach null and you will stop. The moment you stop, the stack will have all the values. Look at the stack, it has all the values. Let's do the step 2 of the algorithm. Step 2 is again taking the temporary, placing it at the head. This time it will be the comparison step. What you'll do is, whatever is the value, and you'll compare it with the top element of the stack. Stack is in last in, first out. So the last entered element was 1. So if you do the top, you'll get the last element. Okay, so you get the top element as 1. And that is matching with temporary. So you say it is matching. And let's move. In case it is not matching, and you'll take it out of the stack. In case it is not matching, you'll straight away return false, stating that it is not palindrome. Let's take out the next. 2 is matching. Let's move. Let's take out the next. 3 is matching. Let's move. 2 is matching. Let's move. 1 is matching. Let's move. And you're reaching null. The moment you reach null, or if your stack is empty, you will be like, okay, all the comparisons were true, thereby meaning it is a palindrome. Very simple. So if I have to write down the code, I think it's going to be super simple. You will basically take a stack data structure. You'll take a temporary, which is pointing to the head of the linked list. And the step 1 will be traversing in the entire linked list, which is temporary is not equal to null. And you'll say stack, can you please push or add, depending on the language that you're using, temporary of data. Done. And then you can say temporary equal to temporary dot next. So that's the step 1. This is the step 1 where you store everything in your stack data structure. Let's try out the step 2. What will be the step 2? You need to compare, right? So again, we will take temporary and this time we'll make it point to head. Never ever alter head because you never know. While you write code, you might require it in the future. So let's go while again do the traversal till we reach the end. Temp not equal to null. This time we'll say if temporary data or value, whatever it is storing value or data, is not equal to stack.tops data. In that case, we will straight away say, hey, this is not palindrome, and we will return false. In case they are matching, what we will do, we'll say temporary, can you go to the next? And if your language, like whatever language you're using, if the top doesn't deletes the top element, you will say stack.pop, so that will pop it out. Once this is done, all the checks are done, and if temporary ends up reaching null, it means it was palindrome. So you'll be returning true. What is the time complexity? Can I say the step 1's time complexity is bgo of 1 because I'm going through the entire linked list, putting everything into the stack. So what is the time complexity for step 2? Can I say bgo of n? Very simple, because again we are traversing. So what is the overall time complexity? Bgo of 2n. What is the overall space complexity? Bgo of n, because we are storing every element in a stack. This is where the interviewer will not be happy with the extra space that you're using, and he'll ask you to optimize it. So let's quickly try to optimize. So we cannot use any external data structure, which brings us to the place that whatever we need to do it in the given linked list. We need to do some link changes, or whatever algorithm is, it should be restricted to the given linked list. Let's try to think. What are we trying to achieve? Compare 1 and 1. Compare 2 and 2. Compare 3 and 3. If the first half is compared with the second half and all the elements are matching, it's a linked list. If one of the elements in that is not matching, it is not a linked list. That's what I'm trying to achieve. What is the problem that we are facing? Like, we can simply keep one pointer at the head. We can keep one pointer at the tail. Match head with the tail. Matching. Move the head one place ahead. Move the tail pointer one place back. And then match it again. But the question arises. It's a singly linked list. It's not a doubly linked list. How do you move back? How do you move back? That's where the problem starts. So overall thing is, I know I need to compare the first half and the second half. That is in case of a even length linked list. We'll talk about the odd length afterwards. But in case of even length, we need to match the first half and the second half. But the problem that is arising is, I cannot go back because the links are in the forward direction. It's not a doubly linked list. Okay. How do we do it? So first thing that comes to my mind is, okay, what if somehow I can change the links and make it like make 1's next pointer pointing to 2, 2's next pointer pointing to 3. In that case, I can stand here and do the traversal. Okay. Changing links, reversing the links comes to my brain. Fine. But for that, I need to recognize which one is the second half. I need to recognize which one is the second half. So step 1 is recognizing the second half, right? Let's try to do it. How can you find the middle of the linked list? Yes, the tortoise and the hare algorithm. In case you haven't seen my video on finding the middle of the linked list, go back and watch it. The link will be in the description. Please go back and watch it. Over there, we did use something as slow and fast pointers. In case of even length of linked list, we had two middle 1 and middle 2, right? What we will try to do is try to somehow reach middle 1. In our middle of the linked list problem, we tried to reach here, right? Let's try to do it. I'll take slow and the fast pointer. First step, slow and fast moves simultaneously, 1 and 2 steps. Perfect, moved. Next step, slow moves 1, fast moves by 2 steps. Perfect. If you carefully observe, this is standing at middle 1. Here's the middle 2. In this problem, you need to stand at middle 1. You will not go to middle 2, which means the fast pointer will be standing at the second last node. It won't go to the last node, or rather null, as it did in finding the middle of the node, because over there we were finding M2. So fast will end up going to the null, Okay. So we need to make sure that we stop when fast reaches the second last node, which basically means fast next should not be null. We keep on moving till that time. The moment the next is pointing to null, we should stop. Otherwise, we keep moving. Perfect. So the first half is done, which is recognizing the second half and the first half. You know one thing, this is the node which is basically slows next. This is the head of the second half. This is the head of the second half. What is my next job? The next job is to make sure the links are reversed so that I can easily traverse. So what I will do is, I'll try to reverse this entire linked list, the second half linked list. I'll try to reverse it. We've already done reverse, right? So I'll call the reverse function and I'll pass slow next. So what will happen is, it will reverse the second half. It will reverse the second half and it will return a new head. It will return a new head by reversing. Once it reverses, how will it look like? It will be something like 1 will be here. 1 will be pointing to 2. 2 will be pointing to 3. 3 will be pointing to null. Correct? Can you tell me one thing? Will the 3 be pointing to 1? No, right? You never changed the link. 3 still points to the previous 3 because that is how the original linked list looked like. You only made sure that these links are changed. These links are changed. The 3 is still pointing to 3. It's still connected. Perfect. I've reversed it. What's my next job? My next job is maybe taking 2 pointers. So what I'll do is, I still have slow here. I'll take 2 pointers. One is the first and the other one is the second. And the second will be pointing to the head. Second will be pointing to the new head. That's where second will be standing at. And let's try comparing. 1, 1 matches. Let's move them. Second goes here and the first comes here. This matches. First goes here and the second goes here. This and this matches. So the first will this time move here, but the second will move here, which is a null. The moment it reaches a null, you say stop, and you are able to compare everything. So it is correct. It is a palindrome. But before returning true, please make sure that you again reverse it. So what you will do is, you will say, okay, please reverse the new head again. So this time, again this will be reversed. So before returning true, make sure you bring back the links back to how the linked list was. So it's like 3, 2, 1 pointing to null. And this is still connected to 3 because you never changed the link. 3 to 2 and 2 to 1. So you reverse it back again. That's how it will look like. So you might be thinking, this is for an even length linked list. How does it work for something like an odd length linked list? In that case, what you'll do is, you'll perform the same scenario, slow and the fast pointers. Do find out the first half and the second half. Slow moves by 1, the fast moves by 2. Perfect. Again move slow by 1. Slow moves by 1, the fast moves by 2. And this is where you stop. So basically you stop at the last node. Which means fast of next is where you stop. Like fast of next should not be null. You will stop at the last node. That's it. You stop at the last. Over here, you stop at the second last. So these are the couple of conditions you have to take care. What after this? You're standing here, right? Let's erase this. You basically again call the reverse. So this will get reversed. So you reverse slow of next. So you will have 1 pointing to 2, 2 pointing to null. And this 3 would be still connected to 2. Do the same thing again because this will be the new head. Do the same thing again. Take the first pointer pointing to head. Take the second pointer pointing to new head. And again do a comparison. Pretty simple. You just have to make sure that it stands at the middle. And for the even node, it stands at the middle one. That is the only thing that you have to take care. So let's write down the code. It will be in 3 parts. The first is finding out the middle. The second is reversing. The third is comparing. Got it? So the first part is finding the middle, right? Tortoise and the hare algorithm. So slow will be head and the fast pointer will always be head. That's where we start off with. And we know the conditions. While fast next is not equal to null, we will keep running it. And fast of next, because we want to stand at middle M1. Next is not equal to null, we will keep running it. Perfect. And we will say slow goes by one step, which is slow of slow next. We will say fast will go by two steps, which is fast of next of next. Perfect, amazing. So what is the next step? Reversing the second half. So can I say node of star, that's in case of C++, in case of Java there will be no star. Reverse slow next, because slow will be the middle, and I'll say the next is the head of the second half. It will reverse you. So that was about the second step. What will be the third step? The third step is comparing. So let's take first pointing to head. Let's take second, which will be pointing to the new head. Do not touch new head. And let's keep moving them. We know the second will get exhausted. Second is the second half and it will reach null after a point. So we will say second is not equal to null. And over here we will say if first data or first value is not equal to second's data or value, whatever it is, we will be returning a false. But before that, please make sure whatever reversal you have done, you reverse it, reverse new head again. So it'll come back to it original configuration and you can return false. You can return false. Perfect. If that's not the case, you will say, hey, first, can you move by one step? He'll be like, why not? And he'll say, second, can you move by one step? Second will be like, why not? And then the while loop ends. After that, if everything has been compared, then it means return true. But before returning true, what is the step? You reverse it. So basically you call the reverse and you say, hey, this thing, can you just get it back to the shape? This is very, very important, specifically for interviews. This is very important because people don't want you to alter the given data. So if you have done something, make it back to the original configuration. That's very important. What is the time complexity if I have to analyze? This is step 1. Can I say bgo of n by 2 because it will go halfway to find out the middle. Perfect. I'm reversing the linked list. So I'm reversing a half section of the linked list. So that's a bgo of n by 2, right? I'm again traversing the first half and the second half together. But can I say, if I go back to the example, I'll end up traversing 1 node, 2 node, 3 node, which is basically half of the nodes in order to compare half of the nodes. So this while loop will be bgo of n by 2 again, right? And can I say I'm reversing again, so which is bgo of n by 2. So technically it's like n by 2 plus n by 2, which is n by 2 plus n by 2, which is n. So the time complexity is overall bgo of 2n, right? And the space complexity overall is bgo of 1. Yes, we're using pointers, but that will not take a lot of memory, not like what stack was taking. So should be it. This is the optimal approach. So let's quickly get back into the code editor and check out the edge cases. If you look at the first line, very simple. If it is an empty linked list, it will always be palindrome. If it has one element, it will always be palindrome. No need to do all these things. Apart from this, step 1, step 2, and the entire step 3. Let's quickly submit it and see. By the way, this one is picked up from our previous lecture. In case you haven't seen, or in case you do not know how to reverse a linked list, go back and watch that. And the other thing is, this is a recursive solution. You can always use iterative in case you don't want to involve the recursive stack space into account. So I've just copy pasted the previous code. That is why I'm using recursion. You're free to use the iterative version as well. So I hope you have understood everything. I'm sure you have. That is why you are still watching. And in case you are still watching, please do consider giving us a like. And if you're new to our channel, do consider subscribing to us as well, because that is the only thing that motivates me to bring more and more videos. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye, take care.
Whenever your heart is broken, don't ever forget your golden